Hey everyone, so my name is Jay Henderson from the University of Waterloo, and I'm here to talk to you today about investigating the necessity of delay in marking menu invocation. This work was done alongside my collaborators, Sylvain Malacria, Mathieu Nancel, and Edward Lank, as a joint effort between the University of Waterloo, INRIA, and the University of Lille. So first and foremost, what are marking menus? Marking menus were developed by Gordon Kurtenbach over 25 years ago, and since then they've been heavily studied and extended in HCI because they introduced this principle of rehearsal in interfaces, so users can move seamlessly from novice to expert interactions. So marking menus are radial menus that rely on two main modes of interaction. The first is a menu mode, where the user presses down an input device, waits for a predetermined delay that's usually a third of a second, and then the menu appears. After this, the user can then move their input device in the direction of a desired command. So in this video, the user moves right, then down to select coffee in menu mode. The second mode is mark mode. So if the user knows the directional strokes to select something, for example, we now know that coffee is right then down, then they can complete the selection without waiting for this predetermined delay. So in essence, users can rehearse the exact interaction to make a selection in menu mode to be able to perform it in mark mode. So as described in the title, we're talking about this particular delay for switching between modes. But since the user is rehearsing the exact same interaction, why not just display the menu all of the time? So prior work has justified this with a few reasons. The first is that the menu can be distracting. The menu can obliterate part of the screen. Displaying the menu takes time. And delay might provide an incentive to use the mark mode, which is expected to be faster than menu mode. So while this delay has received little criticism in the literature, we note a few potential drawbacks. First, the delay can serve as a penalty to users who are unfamiliar with the menu or command. The mark mode requires that users memorize the often arbitrary strokes associated with selection, which may use up more cognitive resources that could have been dedicated to the task at hand. And lastly, users may try to select commands using the mark mode when they're not actually sure if the stroke corresponds to their desired selection, which in turn may increase error rate. So pictured here is a figure from one of the original marking menu papers. However, for example, we would imagine with the advances of computers in the past 2 decades, displaying a menu would take less than 15% of a second. Thus, we wanted to explore a no delay or immediately displayed marking menu, which is shown in the augmented diagram, where the user does not have to wait for menu mode, but can still rely on the recognition of menu items if they choose to do so. We wish to study these two menu interfaces, the original marking menus and immediately displayed marking menus, to see how they fared against each other. So to more concretely visualize this, here is an example of selection comparing these two marking menus that we looked at. With 3 controlled studies, we explored the following research questions. First, are immediately displayed menus faster for command selection? Do immediately displayed menus have a lower error rate? For extremely practiced use, is there a benefit for incorporating mark mode? And lastly, are delayed marking menus with mark mode less visually disruptive? So the first study aimed to tackle the first 2 questions. In our first study, each participant saw both the delay and no delay marking menu in 4 different configurations to get an idea of what typical command selection might reveal. So we had a 2x4x10 within subject's design with factors of marking menu condition, that was either delay or no delay, 4 menu configurations, so 4 item, 8 item, 4x4 and 8x8, and blocks, with 10 blocks of 8 target commands per menu condition and configuration. We'll also note that all interactions were done using a mouse. So, with 16 participants, 2 menu conditions, 10 blocks, and 1 configuration with 4 targets, plus 3 configurations with 8 targets, we had 8,960 selections overall. First, looking at time, we analyzed time as a whole denoted by selection time. So this was the time from the prompt appearing to the user actually making a selection. This was then broken down further into execution time and preparation time. And execution time was the time the user's mouse was pressed to its release, and preparation time was the time from the prompt appearing to the user pressing down. And overall, we found that selection time was significantly greater for a delayed menu, and in the graphs here, we see that overall selection time and preparation time improved for a no delay marking menu. Around block 4 or 5, execution time appears to converge, and preparation appears to move onto separate trajectories. So next we'll look at error rates, and to contextualize this, the top of the figure shows the distribution of modes used by block in the delay condition. So you can see mark mode was used more frequently as block increased. The bottom shows error rate, and we see that a no delay menu appears fairly consistent, but as mark mode use increases, so does error rate for the delay condition. Overall, we found that error rate was significantly higher with a delayed marking menu than one with no delay. So we found that these immediately displayed or no delay marking menus have significant advantages over delayed marking menus for both time and error rate. And even for practice use, in the latter of the 10 blocks, delayed marking menus had higher error rates and reaction times. However, if we revisit this graph, we notice that for execution time, timing seemed to be improving for delay. So we wanted to look into this usage further. Which brings us to the next research question. In study 2, that is, for extremely practiced use, is there a benefit for incorporating mark mode? For this study, to simulate an expert user, we asked participants to perform one of 2 commands to minimize memorization requirements, but to preserve the unpredictable prompt. The study design was similar to the first, but with only 2 menus. Each participant also saw both the delay and no delay marking menu. So we had a 2x2 within subjects design with factors of marking menu condition, 2 target commands to select, and 8 blocks of 10 selections per target. So 8 participants times 2 commands times 10 prompts and 8 blocks resulted in 2,560 selections overall. The graph here depicts each directional stroke with their execution time for no delay and delayed marking menus. So in the extremely practiced use case, we found that the delayed marking menus were significantly faster by about 260 milliseconds than immediately displayed marking menus. We did not find any significant differences in terms of preparation time or error rate. So taking this into consideration, to synthesize the results of these 2 quantitative studies, we found in study 1 an overall advantage for immediately displayed marking menus for time and error. However, in study 2, delayed marking menus showed a time improvement. For our last research question, we wanted to see whether or not an immediately displayed marking menu would be visually disruptive to its users, as was theorized in the original marking menu. So this video shows an example of what the study looked like. We asked participants to recreate the image in the above panel using a marking menu. So the user would spawn the elements of the image using a marking menu. So specifically, we chose this task because we expect occlusion to be an issue when manipulating items with contextual menus, such as rotate, and that there would be many items to select, thus heavy usage of the marking menu. So again, we had a within subjects design where participants saw each marking menu delay type, that is delay and no delay, and had to create 2 images per marking menu conditions for 4 recreations in total. To reduce learning effects, command sets for the menu were different per delay condition. During the interaction, participants were instructed to talk out loud through the process of creating the image. After each marking menu delay condition was complete, participants were asked a series of questions related to their interaction. So here are the results of the qualitative data. The questions were specifically designed to probe for impacts of visual disruption. While there's lots of information in the graph, we only found significant difference for question H. That is, for the condition made me lose focus on my main task, delay was more problematic than an immediately displayed marking menu for loss of focus. The Think Aloud data revealed some more insights on whether or not visual disruption is an issue. First, P12 noted that they noticed no disturbance or disruption since they would always be able to control visibility of the menu by releasing the mouse button. However, P6 noted an issue that they could not see which direction an item was facing, as it was occluded by the menu, so they were unsure of how to rotate it. But participant 15 said the delay condition is slow because users want to be able to do a process as fast as they can without waiting. So we found in Study 1 a reduced performance for delayed marking menus, but increase in timing for Study 2. Therefore, extensive training is required to overcome these performance costs introduced by delay. And since we looked at expertise with only 2 commands, it's unclear whether users can reach expertise with enough of the commands to actually benefit from the delay. In Study 3, we were unable to find this impact of visual disruption that was an issue when marking menus were first developed. This raises the question of whether or not visual occlusion is overstated and whether or not it can be mitigated. So what's next for this work? To start, marking menus are a very unique use case, and it's unclear whether these results would generalize to other rehearsal-based interfaces, so this could be an interesting avenue to explore. Second, while we use the original 1/3 of a second delay, shorter delays, such as those used now in commercial systems, may help to mitigate drawbacks of delay. And while there were some indications of visual disruption, such as the occlusion of items, we wonder if this could be mitigated by, for example, a partially transparent menu so its users can still see content underneath the menu. So to conclude, we presented a quantitative and qualitative exploration of the costs and benefits of incorporating delay in marking menus. As to whether or not a designer or developer should incorporate delay using marking menus, it really depends on whether the system design should penalize novice or casual use to optimize this highly practiced expert use. With that being said, I thank you for viewing my talk, and I hope this paper inspires some future work on delay-separated modes. If you have any questions, feel free to reach out. Thank you.